Hi, in this video, I will be showing you problem number 13 of chapter 8, section 3. A trough is filled with a liquid of density 880 kilometers per meter cube. The ends of the trough are equilateral triangles with sides 4 meter long and vertex at the bottom. Find the hydrostatic force on one end of the trough. The hydrostatic force on one end of the trough. Use 9.8 meters per second square for the acceleration due to gravity. We'll first determine the height of the triangle. Because this is an equilateral triangle, the height will divide the base equally. This part of the triangle is a right triangle. So height of the triangle is h square equal to 4 square minus 2 square by Pythagorean theorem. So it will be square root, this will be 16, this will be 4, so it's square root of 12. H will be square root of 12, which on simplification is 2 root of 3. So height of this trough, the equilateral triangle, will be 2 root of 3. The question is to find the hydrostatic force on one end. So we are going to use the two formulas here. Force equal to pressure multiplied by area. And the pressure is rho GD. Rho is the mass density. G equal to acceleration due to gravity. D denotes the depth. We are going to divide. First we'll place the origin on top of the trough. Then we'll run the x-axis downward as we did the previous problem, and then we are going to place the ith. We are going to find out the force and pressure on the ith layer of liquid. Here the liquid is of density 880 kilometers per meter cube. So then force and then the pressure on the ith layer. Then from there we will find out the pressure on the trough, or the force on the trough, by adding all the forces on each layer, then bringing up with the sigma, which is the Riemann sum, and then Riemann sum will get translated to an integral. So first we will find out the pressure equal to pressure on the ith layer which is equal to rho GD. So rho is given in the problem, G we can substitute later on, which is 9.8. Those are two constants. And depth, so depth above is xi star or xi. So we'll keep it that way. And then Fi, so it is rho Gxi. The pressure, this is the force on the ith layer. Force on the ith layer is pressure on the ith layer times area of the ith layer. So that will be 2. Then in order to do, we know in order to find out Pi times Ai, we already know Pi, but we have to figure out what this Ai is. Ai is area of the ith layer. So that will be length times the width. Length of the ith layer is Wi. The width is width of each subinterval. That is going to be delta x. So all it remains to find is this Wi. So in this figure we'll find out, we will construct the ratio or we will compare the ratio for the measures of the smaller triangle versus bigger triangle. There are two similar triangles. So Wi is the base of the smaller triangle. So Wi over 4, where 4 is the base of the bigger triangle. Then we'll compare the height of the smaller triangle versus the bigger triangle. The smaller triangle height will be the bigger height minus xi wherever the wi is placed, which is at a distance xi from the origin. So the smaller height is going to be the bigger height minus xi. So which is root 3 minus xi, which is a smaller height of the smaller triangle. Then the bigger triangle height is going to be 2 root of 3. So the base of the smaller triangle, which is wi, over base of the bigger triangle equal to height of the smaller triangle over height of the bigger triangle. So from this we can solve for wi, which I have shown here. Wi, so if you multiply both sides by 4, you get wi isolated. Then if you simplify, you get wi equal to 4 minus 2 over root 3 xi. We will call this equation 4. As the question is about the hydrostatic force, we will focus on Fi, which is equal to Pi Ai from equation 2. Then Pi is rho g xi times Ai from equation 3 is Wi delta x. So Fi would be rho g xi, then Wi delta x. Wi from equation 4 is 4 minus 2 over root 3 xi times delta x. Now, the force on the force on the plate or force on the trough is going to be adding all the forces, and also you can also allow number of intervals to tend to infinity. So limit as n approaching, we can consider this to be for now n number of subintervals, I varying from 1 to n, Fi, which is sigma I varying from 1 to n. Fi can be replaced by expression 5, which is rho g xi times 4 minus 2 over root 3 xi times delta x. Now allowing n to approach infinity, we get f equal to integral 0 through 2 root of 3. In the Riemann sum xi and delta x, when it go to the integral, it becomes x and dx. So we make the change. So rho gx 4 minus 2 over root of 3x dx. We have to evaluate this integral. Rho and g are constants. Rho is given in the problem and g is acceleration due to gravity. We can pull that out, which is integral now rho g times integral 0 through 2 square root of 3. Then if you distribute the x, that will be 4x minus 2 over root 3 x square dx. That will be rho g, integrate now, which is 4 x square over 2 minus 2 over root 3 x cube over 3 between the limit 0 and 2 square root of 3. So that will give us rho g, and then substitute the upper limit, which is 2 root of 3. So that will be 4 times 3 minus 2 over 3 square root of 3 x cube, which is 2 cube, which is 8, then root of 3 cube, which is 3 root of 3. The lower limit, it becomes 0. So its F force is going to be rho g, that is a 24 minus 16, so it is rho g 8, which is approximately 8 times, substitute for rho, which is given in the problem, which is 880 kg per meter cube, times 9.8, which turns out 68,992 newtons. Hope this video helps.